So the last question in this section. A force F equals 10 newtons is applied to the 10 kg ring as shown. If slipping does not occur, case, determine the ring's initial angular acceleration and the acceleration of its center of mass. Neglect the thickness of the ring. So this is a problem. Well, this is one of the slipping, no slipping kind of rolling, not rolling disk problem. But the good thing about this problem is you're explicitly told no slipping. It's rolling. So you got to take the rolling assumption and solve it. You do not have to check whether it's rolling, not rolling, because you're already given that it's rolling, it's not slipping. Okay, so first draw free body diagram. Let me just resolve this force. This makes it easier for me to take the moment later on. So the force in the x direction, where we'll call this to be x, xy. The force in the x direction is F cosine 45 degrees, F sine 45 degrees. So that will just help me to take the moments later on. mg, acts at the center of mass. N acts up. And then the friction force okay, so those are the forces on the ring. Okay, so let's now solve for the two unknowns, acceleration and angular acceleration. So F x equals mass times ag in the x direction. So the net force in the x direction is F cosine 45 equals mass, which is 10 times agx. I'm forgetting the friction force. Write that down. Minus friction. So I'm basically following the same procedure as I did last class. I wrote down those three equations using Newton's laws. Fy equals mag y. So that gives me n minus mg equals, I'm forgetting something again. N is upwards. F sine 45 is also upwards. Equals minus mg equals 0 because the acceleration in the y direction is 0. And then moment equation, we call this 1, we call this 2. mg equals ig alpha. And so we need to find the net moment about g. So we see that there are, well, in this case, there are, if you think of the F cosine and F sine as separate forces, then there are 5 forces, of which mg and n do not contribute to the moment at g because the moment arm is 0. The only three forces which contribute are ff, F cosine, and F sine. So ff has a moment arm of 0.4, the radius of the ring. And about g, the force ff would create a clockwise torque, so negative sign. Then there is F cosine 45 degrees, which has a moment arm. I need to find this distance. So that distance is 0.4 plus 0.4 sine 30. That's because this distance is 0.4 sine 30. This is 0.4. So 0.4 plus 0.4 sine 30 degrees. And that acts in the clockwise direction because F is above G, and so above G it's going to create a clockwise torque. So negative. And then I'm going to continue in the next line. F sine 45 has a moment arm equal to the distance from here to here, this distance, and that is 0.5 cosine 30. So F sine times 0.4 cosine 30 degrees, and we can see that F acts upward about G. It's going to create a counterclockwise torque, so positive. Equals Ig. For a ring, the Ig is mass times radius square times alpha. So this, let me call that equation 3. And then finally, the fourth equation is okay, so why don't we take, I'll just change the convention here. I'm going to take alpha is clockwise. Okay, I'll show you what happens if you take clockwise. The previous times I've taken it to be in the counterclockwise direction. If you take alpha as clockwise, then the only change you'll make is this. There's two changes. You'll make, one is you'll put a minus alpha because now it's clockwise, and our convention is counterclockwise positive. And the second thing you'll do is Ag equals R alpha will be all right because R alpha leads to a clockwise Ag, and so that's right. So these are the four equations. The unknowns are N, Ag, alpha, and the friction force. Four equations, four unknowns, and you can solve for Ag and alpha. So Ag equals 0.224, and alpha is, I'm only writing down answer for alpha and Ag, 0.56 radians per second square. Okay, so that is fine. So this is following the same procedure I did earlier. However, this is actually a longer way of solving it, although it is all right. It's a longer way of solving the problem is because you end up generating four equations and four unknowns. The two unknowns which we do not care about are N and FF. We do not care about these two unknowns because we have been asked to solve for those two unknowns. So if you solve it this way, you get the right answer, but you'll end up solving four equations, four unknowns. The shorter way is to try to write equations so that you only solve for things you care about, which in this case is Ag and alpha. And you can do that using just two equations. So I'm going to show you another method of solving this. It won't take much time, and I'll let you go. So we'll call this method 1. Here is another way. So again, only two things we care about, Ag and alpha. Okay. If we write the equations in this fashion, the way I've written down, we will end up with friction force, and we do not care about the friction force. So the way you eliminate friction force is, instead of taking moments at G, you take moments at C. And when you take moments at C, C is this point, friction force will disappear from the equation, normal force will disappear from the equation, mg would disappear. So previously when you took moments at G, only two forces pass through G and they would be eliminated. But here three forces pass through G, and so three of them will eliminated. So let's do moment about C is, and actually the formula changes slightly. It is Ig times alpha plus R G to C cross with MAG. So the change is that you need to have the second term in that equation. I wrote it down in the previous class. So let's try to write this equation. MC is the moment about C. We can see that there are two things contributing to the moment. One is F cosine 45 and the other one is F sine 45. So F cosine 45 degrees. We need to find the moment arm about C. So we need to find this distance. I think I did a mistake here. F doesn't look right to me. When I did just going back, if I took moment about G, and so I should have taken only this, right? This part shouldn't be there. This is not right. Because it's only going to be the distance from F cosine 45 to G. So please correct this. This part, this shouldn't be there. 0.4. Okay, because it comes right now, it will come because now we are looking at the distance from the ground, which is 0.4 times 0.4 sine 30 degrees. Put it down here. So 0.4 plus 0.4 sine 30 degrees. And the effect of F cosine 45 is to create a clockwise torque, so it's negative. Then we have F sine 45. We'll write in the new line F sine 45 degrees, and about C it's going to have the same distance as previous. This distance is 0.4 cosine 30 degrees, and it's going to be in the counterclockwise, equals Ig alpha, so mr squared times minus alpha, because I took alpha to be clockwise. And then this piece, we've never actually written down this piece. Let's see how do we write this down. So this is representing the moment arm due to MAG. Okay, how is AG? AG is to the right, and the vector from C to G is this, G to C to G. So there are two ways to think of it. One is you actually take the moment by using the cross product. So I need to curl my fingers of my right hand from GC, which is upwards. So GC is upwards, AG is to the right. So I need to curl my right hand from GC to AG, and my thumb gives the direction for that moment. So it's going to be negative K. That's one way to do it. The second way to do it is think about moments. MAG is a force, and it's going to cause a clockwise torque about C, and a clockwise negative. So both ways we get the same answer. So again, repeating, two ways to do it. One is if you like vectors, do the cross product. The vector from C to G is upwards, AG is to the right, this way. And so I need to curl my fingers from G to C to AG, and so the thumb gives minus K to be the moment. Or the simpler way I think is MAG is a force which is acting this way. About C is going to create a clockwise torque, which is negative. So negative MAG, which is unknown, and then the distance from C to G is the radius, which is 0.4. Okay, so that's equation 1. The second equation is AG equals R alpha. So we have two equations and two unknowns, AG and alpha, and so you can solve for the two unknowns using the two equations. That's a shorter way of doing the problem. If you're not asked for friction force, use this method. In fact, after you use this method, you can actually solve for friction force easily. I would recommend the second one over the first. Okay, so I'm done with chapter 17. We have a brief part about chapter 18 on Monday. I want to stick to the schedule, and on Wednesday I will do a review for the exam, which is on Friday. I've already posted mock questions. Please go through them, and I'll send you more details as we go. But what I would say, this part is important. We've always asked questions on this part. If not in the term exams, it will show up in the finals. Sometimes we do ask questions in both the term exams as well as in the finals.